So this session, as we know, we are going to do some hands-on because this just after lunch, it's the best time to sleep, so we don't want you to sleep. So we will do some hands-on sessions. So I'll just give you some introduction on the introduction you already got, what's the platform and everything. So I just give some introduction on how to use the platform. Yep, we'll start, yeah. So this is just an overview for what we will discuss here and what we will do after, for 2 hours from 2:10 to 4:10. So I will just give some software overview, how the software looks like. I think you saw all the hardware components and everything that is currently present in ARA. Then I will give you how the experiment will look like. What are the major steps in ARA experimentation? Then we will just go through the ARA user manual. What are the sections in user manual and how to navigate through different sections and how you can find out the information on what to do with the platform. Then I will just discuss 2 of our important tools that's for experiment automation. How you can automate experiments and share your experiments as files so that your friends or colleagues can actually perform the experiments, and then just a simple introduction to how to contribute to ARA. Okay, so we need to make it a little bit quick. So you know that this is the current ARA platform. You can see the map, and you can see a lot of dots here. So just a quick information on what are these dots actually. So these yellow ones are actually the base stations, the cellular towers, and the green ones are the user equipment. Okay, just like your phone. Okay, and you can see we have currently 7 base stations and nearly 40 to 50 user equipment. Okay, you can use them. So these are the resources available. Then this is one of the most important resources, these red lines actually. So you know that in cellular network, the base stations are connected by fibers, right? But in rural settings, we don't have fibers. So we are actually trying to connect all the base stations through high capacity, long range wireless links. Okay. So what are these wireless technologies that we use? We use millimeter wave, microwave, and free space optical. Okay. So we have millimeter wave and microwave in all the links as of now. And this link specifically, we have an additional free space optical link. Okay. So ultimately, all these red lines are 2 parallel lines. One is millimeter wave and one is microwave. And this is having an additional parallel line that is free space optical. And we have some mobile UEs. I don't know whether you observed some buses going here, right? So we have some UEs actually deployed on bus, and one is actually on a fire commander vehicle. And this base station, this Wilson Hall base station, is actually connected to satellite network. It is OneWeb satellite network using a huge terminal. So we have one experiment for that as well. So this is the setup. You have any questions on this? Because the spatial ID is actually very important for us to work for the experiments, right? Why I am saying, because it's not like a AWS cloud or something. Because when you ask for some compute resource, it will allocate the compute resource wherever it is, right? Wherever it is free. But we cannot do that here. Let me change that. Okay. So we cannot do that here. Why? Because this base station cannot connect to this UE, right? Because it's too far. So we need to connect this base station to this UE. So there should be some kind of specificity to the base stations and UEs that you are going to use for your experiments. Okay. So the space and the spatial idea is actually very important. Any questions on the spatial distribution of resources?
Connected to which? That far.
Which one?
The one that far. In the middle.
Oh, this one? This one? This is a base station. Huh? Oh, this one?
Yeah,
Oh, this one, right? So it depends on the technology actually. You know, one base station for us, it means 3 base stations because we have 3 technologies, right? One is software defined radios, and another is massive MIMO, and another is COTS. Okay. So if it is massive MIMO, the range is actually very, I mean, you can go up to 10 kilometers. But if it is a SDR, or SDR can go up to a few hundreds of meters, and COTS can go up to maybe 1 mile or something, right? So it depends. So you can say that I think this will connect. For this, it's very difficult to connect to an SDR base station, but it can connect to a MIMO base station because it can go up much farther. So it's connecting to here. I don't know whether it is here or here. I think it's here. Yeah.
Share your screen because this is not appearing actually in text.
Oh, okay. Yeah, give me a minute. Let me connect to the WebEx. Okay. So any more questions? Okay, if not, we will go to see how you exactly specify the resources, right? So you have base stations, you have user equipment, you have some other resources. How exactly you will specify the resources? That's very important. What is the meaning of an ARA resource, right? So usually an ARA resource is specified by 3 things. One is the deployment site. So where exactly, at what geographical location it's actually deployed. Then what is the device type you will use? Whether it's a RAN resource, you have the RAN resource and you have the backhaul resource. So what kind of a resource it is? Even if it is a RAN resource, whether it is a base station or if it's a UE. Okay, so that's actually the resource device type, you can say. And there's a device ID associated with it. Why we need a device ID? Because in a particular geographical location, you have 5 or 6 UEs, right? So you need to specify which UE at that location, right? So it's a kind of a 3-digit device ID. It's not shared. I shared my screen. Okay, let me stop. So now I stopped, right? So share, right? Maybe I can share only the keynote.
Okay, try.
But I want to show the web page also later, the website. So it's better to be screen.
Oh, go to screen. Sharing feed.
Maybe let me try. Okay, yeah.
Okay. Thank you.
Okay, so that's one thing. So how we will specify, for example, as I mentioned, so if you want to specifically want to create a private 5G network, as an example, so you want to use this Wilson Hall base station and this particular user equipment. So you need to specify Wilson Hall, that's the geographical location, the deployment site. Then BS is actually representing the base station, that's the resource type, and this is the ID. That's the first base station here. And you actually need to use any of the UE. You can see all the resources are named in the same manner. there's a deployment site and the type of the resource and the ID. Okay, you can see that. So that actually will make you to see, okay, I want to make a private 5G network here, so I need to use this, right? So same is the case with, if you want to do some experiments with this particular link, for example, this particular link. So you can use, these are the two base stations that you are going to use, but these links are associated with a host computer where you can actually try to run the experiments. So usually it will be boon host 000 and agronomy farm host 000, so that you can use this link for your throughput or delay experiments. Okay? Any questions? So we have different types of resources, as I mentioned earlier, right? We have some compute resources. For example, we have some computers in data center that you can use for specifically for computer, for some computing activities. For example, if you are creating a private 5G network and you want to run your core network, that's actually a compute. That's a compute resource is required to run the core network, right? So you don't need to run it in the base station or UE. You can run it in the data center. So we have some computers in data center, right? You can see here some edge computers are there in some of our base station sites, not all. Then, as I mentioned, there are base station and UE sites. You can use something like this. Then we have some other resources like the weather stations and distrometers. That's a different kind of resource. What's the difference? I will tell. So for using any resource in ARA, you need to reserve it. Okay? If you want to use it, you need to reserve it. If you are reserving this resource, no other user can use it. Okay? This is very important when you try to start your experiments in the hands-on session, because a lot of people will try to reserve the same resource, then it will create a lot of collision and it will say no host available. Okay? So one important thing is that you just follow what your our member responsible for your team is saying. Don't try to reserve the resources on the fly. Okay? Because it's not like a shareable resource at a particular time. So if one person is using these two resources, nobody else can use that resource at the same time. So somebody else should reserve some other resources. Okay, that's important. Then that is for some kind of resources, especially that involves some kind of computing, base stations, UEs, then some of our edge computing nodes or simple computing nodes. But there are some other resources like weather stations. You don't need to reserve it, because from weather stations, you are not going to configure the weather stations. You are just receiving the weather data, right? So it's like a read-only platform. So you can use it from any computing node. You can use it for your experiment. So you don't need to reserve. Just use the APIs that we are providing so that you will get the data. So that's one thing. So how exactly, so now you know that these are the resources that is spatially distributed. This is the way we will specify the resource. This is the way to reserve. Then how you will use it, right? So in the email that we sent, we asked you to register for the ARA portal. I think some of you did. So what you will do is I created an account for you in the portal. So what ultimately when you log in, what happens is that you are logging into our data center compute session. Okay. We have a controller running here. So this is the portal that you actually logged in. So you will log in and you will see all the resources in ARA inside the portal. It's like a web portal. Okay. Then what is the next step that you will do is that you will reserve that particular, for example, if you think that this is a base station site, you will reserve it. Then once you reserve it, it's just a reservation. Reservation means that nobody else can use it. Only this person can use it. That's the only meaning of reservation. Now, how you will get access to it? That's important, right? So the next step is you will actually launch a container on that particular resource. Okay. How many of you are familiar with Docker containers? Yeah. So you will ultimately launch a Docker container on that resource. Then you will get access to that container, not to the bare metal as of now. Okay. So you will get access to the container, and the container is actually attached to your radios, wireless radios. So you can control the radios using the container. Simple. Any doubt? That's the experiment workflow, actually. Okay. So once your experiment is done, just delete the container. That's all. So you can see here, you can, if you are reserving a particular resource, you can launch multiple containers. It doesn't necessarily mean one container or something. You can launch multiple containers on the same machine. That doesn't matter. But you can actually launch container. Then inside the container, you can run your applications or the experiments. So this is a basic software architecture. You can actually find it in our user manual. So this is the experiment workflow that I mentioned. So you are just logging as a user, then you will reserve that particular resource, then you launch the container, then you will get access to the container, then you will do the experiments. After the experiments, the experiment container will be deleted. Then you can actually reserve resource, you can release the resource that you reserved, then log out. That's all. Is it clear? Any questions? I can just show you a simple demo so that you will be clear how it is. So you know that there are two types of login. One is using username and password. That's not recommended. So that's why most of you probably log in using your university credentials. So we are using a platform called Globus Auth that will allow to log in using your university ID. So you don't need to share a password or something. So that's a kind of a single sign-on system that we use to log in. And this already I mentioned. And you know that if you are familiar with Docker, you are actually launching containers, right? So we have pre-built containers for different experiments. That baseline containers you can use to build your own experiments. Okay, so all those containers are actually public. So we have a Docker hub that we maintain, so you can use it. All the images are public, and currently we allow users to launch containers only from our repository. Okay, so if you have specific requirements or something, just reach out to us. We will customize the containers and we will create images for you. Okay, it's just for the security purpose. Just for some information, we have 19 examples that we provide specific to individual platforms. For example, just related to the compute and edge node, we have 2 example experiments in our user manual. Then related to the RAN technologies, you can see GNU radio based experiments. We have 3 MIMO experiments. We have 5G RAN open air interface. We have 1 indoor and 1 outdoor. Then we introduced SRS RAN. Because last year, AraFest, we primarily did the open air interface. Today, we are going to do the SRS RAN experiment. That is also their indoor and outdoor experiments. Then we have a spectrum sensing, then quartz channel measurement, and 1 ORAN experiment you can try. Then with respect to the backhaul, the ARA haul, we have microwave and millimeter wave. We have 2 experiments. Then free space optical link experiment. We have 2 actually specified in the manual, but it depends on the stability of the link. So we are not going to do that today, but we are going this one. If you are interested, you can try the satellite backhaul experiment. We have only 1 resource with satellite backhaul. So I don't know, maybe that same resource will be used for this experiment. So it may not be available for now. But after this, you can try the satellite backhaul experiment. Then we have 1 experiment specifically give some information on how you can access the weather data from our weather stations and distrometers. So these are some experiments. Then I will just show you the experiment workflow. Probably, let's see. So you know that our portal is actually portal.arawireless.org. So it will ask for Globus Auth or Keystone credentials. So you can give Globus Auth. Then if you do the sign in, what happens is that it will, because my credentials history is already there in my in my browser. That's why it directly logged in. Otherwise, it will ask for you to, it will take you to your university's login page. So where you can give your email address and password to login, right? So just for our some information on the portal, when you log into the portal, it will first go to the overview page. So here you can see the list of all resources and their status. Okay. So these are the compute nodes. So you can see the compute nodes, whether it is reservable, available, or not available. So you can see 1 column reservable. Okay. If this reservable is showing as available, you can use that resource. That's the meaning. This is very important. Okay. So some of the users, they will not check this and they will go and they will try to reserve the resource and it will show that it's not available. So this is one resource, right? The compute resource. So you can see that out of 4, 3 are available. Then if you go here, you can see the SDR base stations, right? SDR base stations, how many of them are available? So now all of them are available for reservation. And you know, each base station is having 3 radios for 3 individual sector, right? So you can see the status of all radios, right? Whether SDRs are available or not. Same is the case with user equipment. If you go here, you can see you can just sort it. If you want to know which are the available, just click on the reservable. It will actually sort according to the availability. So you can see all the resources here with the specification that I mentioned before. Kitchen farm UE000 means it's a UE deployed at kitchen farm. It's the first UE at kitchen farm and it's available, and how many SDRs. And as I mentioned, you can see each UE is actually having SDR, the MIMO, and the codes. So individual radios, whether they are available or not, you can see. So this is just a first thing that you need to know to reserve some resources and do some experiments, right? So I'm trying to give you a small introduction on how to reserve and launch the resources. So if you go here, you can see reservations, and there is a menu called leases, right? If you go there, so now I don't have anything, right? So I just want to reserve one compute resource, for example. So I will create a lease. Okay, so what I am going to do is that I will try to switch and show you so that you will see the spatial feeling of what it is. Let me go to AraWireless.org. Then we have the deployment. Oh, okay. So if you go here, you can see the map, right? So this is our platform, right? So if I go here, so we have ARA data center here, right? So we have some compute resources here, data center, compute 000 and 001. So I just want to reserve one compute 000, right? How I will do that? Let me stop sharing and share something else for the WebEx team. Share. Okay. Are you able to see my browser now, Salim? Okay. Okay, so I'm going to just reserve this compute resource. I have a compute resource here and in my data center. How I will do that? So let me go to my portal. So here you need to just give a lease name. For example, I will give something like my compute lease. Okay, and you can give the start date and end date for your reservation. Okay, if you leave it blank, it will be 2 hours, and the maximum allowed is 5 hours. Okay. So I will just give it this one for blank for now. So, okay. So in the next phase, you need to create the lease. Here you need to actually specify which resource you want to use. As I mentioned, first it will ask for the site, right? So these are the deployment sites available. So I will just give the data center here, and there's a compute node, right? Data center compute 000 I need to use. So I will give the device type here, compute, then I will give 000, right? Then I will just create lease. So when I create lease, you can see that the lease will appear here. Yeah, it's actually the lease created. Initially, it will go to the pending state, right? So when you just refresh multiple times, you can see that it will be active. Okay, when a lease is active, you can actually launch containers on them. Okay, it will take maybe 5 seconds or 10 seconds for a lease to be active. So now I reserved the compute resource, nobody else can use it. Is it clear? That's the first step. Now what I will do, I need to launch a container to access that resource, right? So there's a container tab here, go to containers. Then, so there is a create container button here. So similar to that, you can give a container name, my container. And this is the image that the Docker image that you are going to use for for your container. Okay, I will just use a simple Ubuntu image here, then just give a command bash here. So then you can give a host name, something like a compute. Then here it's important. You are launching container on a particular lease, a particular reservation, right? So I created a reservation called my compute lease earlier, right? I need to select on which reservation I want to launch the container. So I will just select that and I will go then select a network here, then create the container. Okay. Let's see. Yeah. Oh. I have a doubt. Somebody else is creating containers on that already. Oh yeah, it's running. Okay. Usually if somebody else is doing and the quota will be exceeded and we may not get the. Okay, so the container is actually in the running state. And if you go to the console, usually you will get access to that particular container. See, I am in the container. So it means that I am getting access to that particular resource. Now I can use it. Is it clear? This is actually a shell to that resource. Yep. Yep. That I will tell you. Right. So if you look at this one, right, this is actually a terminal in the web browser. This is not a good one, for example, right? This is just for some preliminary purpose. So you can actually set a password for this container here, right? So I will just give a password here. I need to just set a password. Okay. Then I need to, so ultimately, as programmers or engineers, we want to work with shells or terminals, right? So we want to SSH into a particular machine and we want to do it, right? So we don't want to do it from a web browser. So you need to just start the SSH service. You can say service SSH restart. Okay. So that's fine. That's just a setting. Then one important thing is that if you are in your home or somewhere, right? Okay. It's taking some time to load the container. Okay. How you will log in SSH to that particular container from your home outside ISU, for example, outside iOS state, right? How you will do SSH. So there is one important thing called floating IP address here. You can see, right? So we are using some kind of a gembox kind of 2-hop access to the container because this IP is not public. So you cannot do direct access. So we are providing a gembox. So that gembox you can access from anywhere in the world. Okay, you can create an account. There's an instruction in the user manual. So you can create Gembox, then log into Gembox. From Gembox, your container is accessible. Okay, so I will just use my terminal. For example, I will use this. So I just put an box. Okay, so this is an SSH. I just put an alias for that. That's why it's actually do an SSH to the Gembox. So when you do that from anywhere from the world, you will get into our Gembox. Okay. From Gembox, I will use the floating IP to SSH into my container, right? So you know that my floating IP, let me check. It's 10.189.11.131, right? So just go here. My username is root. Then I will put this. Let's see. Yeah. Then I will put my password that I set here. So now I am in container. Now you can do it. Got it? Any doubt? Okay. So that's all. Then you can run whatever commands in the container. For example, you will run anyway. You will run in the next couple of hours, right? Then once it is done, what you can do is that you can just go. Your experiment is done. You can just delete the container or just delete the lease. Delete the lease will automatically delete the container. Okay. So from here you can stop and delete the container. Then you can delete the lease. Okay, that's all. That's all the experiment workflow. Any doubt in this? Just create lease, create container, do your experiment, then delete the container, release the lease. That's all. Is it clear? Okay. So we can go quickly to the 2 additional tools that I just want to demonstrate to you so that you can try it at your home, probably. Let me see. Okay. I need to change my WebEx again. Stop sharing and share my screen, keynote. Share. Okay. Okay. So this is kind of a manual mode of experiment, right? You are creating lists by your own by clicking the buttons and everything. But that's not actually good for the long run. You want to automate your experiments, right? There are two tools actually we are giving to automate your experiments. So one is actually called experiment profiles. Okay, whatever I did here, reserving lists, launching containers, and everything, you can actually specify as a YAML file, something like this. Just a file. Okay, then just upload the file and just launch that particular thing. Then your experiment will be, instantiated. For example, that leases will be created, containers will be launched, everything in a single click. So this is just a kind of a settings file. You are specifying your experiment as a YAML file, that's all. So if you want to share the experiment that you created with your colleagues, right? Just create a YAML file, then just share it with them. So they can just download it, just upload it, just experiment is done. I'm not going to do a demo here, but just I am saying these are the tools. And this is the next one. You know the issue with this one? Any disadvantage for this one? One thing is that you need to write a lot. That's one thing, right? As the experiment specification, there are some crazy keywords here. You need to use this. And another thing is that, for example, you want to try something, right? I can tell you one example. You want to start your throughput measurement when the rain starts. Okay, you are continuously monitoring the rain, and you want to try to start your throughput experiment when the rain starts. How you will do this? It's a difficult thing because it's not a programmable experiment, I can say. Okay, it's like a static experiment, you can share it, right? But if you want to do that, you need some kind of a programmability in the experiment, right? So that's why we actually providing another platform called Jupyter Notebooks. You know Python, right? Everybody knows Python. So we wrote some APIs around ARA platform so that you can use that APIs to do some kind of a programmable experiment. So you can actually launch containers from Python functions. Then you can run experiments in the containers using Python, and you can extract the data using Python. Then you can do all such kind of processing using Python. Okay. So what exactly you need for doing a Jupyter or writing a Jupyter notebook? As I mentioned, the fundamental thing is the experiment workflow. So we actually created a library called ARA client. It's a Python library, and we have specific APIs for the experiment workflow. So this is the first step, right? So there's a create lease, there's a function, and using this function, you can give the information, and this will create actually a lease from Python, right? Then it will actually return a lease object. If you know Python, you know what is an object. So there will be a variable that will be returned, and this is a lease object. And ultimately on the lease, you want to launch a container. So you will use the lease object and create container to launch a container. Then within the container, you want to execute some commands. This is ultimately your experiment. So you can do that. Then once your experiments are done, then you can delete the container and delete the lease. Okay. So this feature is actually available in ARA. We are not going to do that during our experiment session, but if you go here, there's a Jupyter notebook here, right? Then here you can actually write your Python examples, Python experiments. Okay, this is another way to share your experiments with the community. You can download your experiment as a Jupyter Python notebook, and you can share it. This is just I just wrote today morning just to show you how it will look like. I am just importing my ARA client library, then I am creating the lease information, for example, site, resource type, and everything. Then this will actually create the lease. Then this can display the lease information. Then I am creating a container in that. So all the information is given here. So whatever I showed you before, right? Clicking on the lease and everything, it's like just like 7 lines of Python code. Okay, this you can try. This is actually available. Last year I just showed the initial version of it, but we made it actually public, and the detailed instructions are there in the user manual. And yeah, that's all for the presentation. And these are some of the resources available. ARA portal is available. Actually, I send you an email. You can see the portal link there. Then user manual is available here. It's if you go to the ARA website, you will be able to see all this information, right? ARAwireless.org. If you go here, you can see the deployment. Oh, where it is? Oh yeah, here. Login. This is the portal. This is the user manual and everything. Then, yeah, we have a contact here, e2@arawireless.org. Then we have a Google Groups you can join, because most of our notifications or everything will be, we posted it in Google Groups. If you already joined, you might have seen my notifications on the resource unavailability for during the weekend. Then every Tuesdays from 5 to 5:30 Central Time, we have office hours. It's open, anybody can come, and we will be available to discuss. Then if you face some issues or errors or something, you can just send an email to support@arawireless.org. Then we'll be able to, we'll respond and we'll handle that particular request. So that's about my slides, and just a quick overview on the user manual. This is the most important resource if you are doing some experiments with ARA. So you can see an overview page, some information like the what is ARA, how to getting started with it. Then the software architecture I defined here. Then this is also very important, the portal features here. It will give some additional information on how to collect the data, how to set up the Gembox account and everything. Last year, I think if you remember, those who are attending here for the second night, it took some time for uploading your Gembox public key and everything. Now we automated it, so you can do by yourself. Then this is another important thing. I don't want to explain it more because of the time constraints. If you are writing your own experiments using Profiles or Jupyter Notebook, right? If you want to share it with the community, we are actually providing a GitLab-based platform. So you can upload your experiments and everything to this GitLab. All the procedures are here so that other members in the community can use your experiments or build on the top of your experiments. Then the next section is ARA experiments. Here you can see the platform-based experiments, different experiments available. If you go here, ARA, and you can see the open source 5G experiments, AURA and TV Whitespace, codes and spectrum. Then ARA whole experiments, we have the wireless XOL you will do today. Then free space, optical, then satellite, then some additional experiments like the weather station collection, some of the edge experiments. Then if you want to do weather collection, some of the APIs are listed here. And there is some frequently asked questions here, because some of the errors you will get, you can, sometimes you need to retry and you will get it corrected. Yeah, those are the important things. Then I will stop here, then we can go to the hands-on experimentation. Any questions? Yep.
So you want to test measurements while the rain starts?
Mm-hmm.
With the Jupyter Notebook.
Right. Huh? Oh, it's actually easy, right? Our Python library is actually accessible, right? We see everything is Python in that. So I will just give a short answer for this. So this will show you how we can collect the weather data. Okay. So you can actually just, we have a library called AraWeather. So just import that and get the weather, and you will get the weather in a dictionary. So from that dictionary, you can check whether the rain rate value is more than 0. If it is more than 0, you can launch a container. And so you can apply that if conditions and everything in Jupyter, not in the other one. Yeah. Yeah.
Like that requires like continuous monitoring.
Yeah.
It might just be like better to, it might just be better to like have the ARA client available as a library, like so we can run it on the background somewhere else.
Oh, you mean, oh, this is actually public. Oh, you mean the ARA client library?
Yeah, because like I don't know how exactly how these runs. Is it like persistent, like the
Yeah,
Jupyter notebook?
for 5 hours it is persistent.
They say only 5 hours, right? Not
Yeah,
24/7.
Currently, the
every
thing
day.
is this, right?
If I answer the question correctly, right now, basically, I schedule a job. In that job, I can run this, right? But it may happen so that in that duration, the weather is always false. What if in my job specification, I just say run my job with this weather condition, then
Right,
whenever that weather comes, run my job for 2 or 3 hours.
right.
I think that's a request. What? No?
But also, no, like I'm just focusing more on like the Jupyter experience, Jupyter notebook experience, because like it's not what you're trying to do like when you're running a very long job, which is like when you try to monitor the
Right.
weather.
I mean, your job can run up to 5 hours, right? In between the weather happens, I mean, it can work.
Yeah, I guess so.
Right?
Yeah.
Another important thing is that you can continuously monitor the weather without reserving any resource.
Yeah, that's what I
That
mean,
can be
right?
done.
That's that's
So
what I
you
mean.
can continuously just monitor the.
And then
because
if the weather's changed, then you
reserve
create the
resource-
reserve.
That's perfectly fine. Yeah.
So there's actually this notion of it's a feature we have not fully enabled.
Yeah.
This weather triggered experiments,
yeah.
right? You can actually define experiment that will be triggered automatically for you when certain weather condition hold.
Right.
That's something we
We are
can
working
do.
on that. Yeah.
Yeah.
I mean, instead now you know that there's a start time and end time for the reservation, right?
Yeah.
So instead of that triggering, we can have the weather triggering.
Something of the
Yeah. Right. We are working on that. Yeah. See, it's not finalized to make it public. Yeah. Any more questions? Yep.
What if I don't have?
Huh?
I haven't registered for the report.
Oh, you can just in the email package that we sent, right? There is some instruction, right? So there is a sign up form. Just fill that. I can create an account for you. That's a Word, Microsoft Word package. Oh yeah.
All right. Any other questions? Yeah.
So can we create like personalized containers for us?
Currently, our approach is like
The safety.
safety. Yes.
That should be yes.